Cisco Certified Network Associate Day 47. Welcome back everyone, I'm Imran Rafa, your trainer for this entire series. Today we're going to talk about OSPF troubleshooting and we will continue from our last video. So without wasting much time, let's get straight into today's class. Before we go ahead, click on that subscribe button if this video and this series has helped you, and don't forget to hit that bell icon next to the subscribe button once you subscribe. If you like this video, we would also appreciate if you hit that like button. So what are we going to look at in today's video? Today we will continue 2.4, and today part of the 2.4 we will look at the troubleshooting part, and the few concepts that we need to introduce. That's what we're going to look at. So we'll get straight into packet tracer. Alright, so like we promised in the last video, we will look at this troubleshooting and we'll try to solve this problem. First thing I just remembered is there was a typo. This is not, there's nothing called 192.168.4.0. This is 10. What was that? Okay, let me just quickly check. It's already configured on this router. So show IP interface brief. So it is 10.1.1.5 network. So it is 10.1.1.0/24, right? So this is the 20/24 network for 10, right? So like we promised in the last video, we'll start with day 46, OSPF verification. This is a topology that you can download from our website. I'll put the link for this resource on from our website. It was available in the last video description, but even you could find that same in today's video description. Look below, right? So please download if you have not downloaded, and we will try to solve this as a troubleshooting task. Our task is the PC0 needs to ping to PC1, and PC0 needs to ping to PC2, and PC1 should be able to ping to PC2, right? That's the task. Let's check if it is pinging. Obviously it wouldn't, but let's just try. Ping 192. If I remember, PC1 is 192.168.3.10. It's not pinging. It's saying reply from 192.168.5.1, which is this router. It's destination host unreachable. Now when you see destination host unreachable, most probably, or rather that is the case where the router says he does not know that route, right? So that means the routing table for router 5, which is this device, he does not have any information for 192.3.network, right? So we can go there and verify that. Show IP route. When I say show IP route, it does not have anything with 192. It has I mean, because of OSPF, it has learned this network, it's learned the 2 network, learned the 4 network. It has obviously directly connected to 5 network. It is connected to the 10.1.1 network. Of course, that's this network. Then 192.168.0. It's learnt on OSPF, obviously, and 5.0 network is this network. So it doesn't know anything about 192.168.3 network. So that could be because see, OSPF is running and it's not learnt about 3.0 network. That's because maybe 3.0 network is not getting advertised. So let's go here and let's see what's happening. Show run pipe. Now this is something you can do. You can do pipe. And packet tracer only has pipe is more like a filter. So here you can have begin. That means it will begin from that section. If you say include, it will only include lines which has that particular word that you give. And when you say exclude, it will not show those lines which has the expression, right? So let's say, for instance, when I say begin router, so from the router section, it will start showing you the running configuration, right? That's exactly what I want. There is another command which says section. Some of the routers has that, which says section, so they only show the section of the router, right? This section. But anyway, we don't have it here, so I'm going to use a begin. So so here, this is for router 3. Router 3, 192.168.1.0, that is this network is being advertised. 4.4.4 is loopback. Loopback is advertised. but this network, it is not advertised here, so that's the reason router 5, which was this one, is not seeing 192.168.3 network. So let's solve that problem. So we go configure terminal router OSPF 1. Come here, we say network 192.168.3.0 and 3.0, yeah, and it is /24, right? /24. So it is 0.0.0.255 area 0. I hit enter. SPF should be recalculated, and you should have a route of 192.168.3.0. Network is ready here, right? Now will it ping? So let's try that again. Now it's not giving you the destination host unreachable. That means from here the packet is going out. The packet is going, it is going depending on what is there. So we'll look at where it is stopping. So it's going somewhere, but he's not getting a reply back. Why is that? So from here it goes, then it comes to router 3. So router 3, let's see if he knows show IP route. He knows 3, he knows 1, but he doesn't know about 5, and this is the 5 network, and that could be, let's do the same thing here, show run begin router, and we see this network, this router is not advertising the 192.168.5.0 network. So let's go back to router, configure terminal router OSPF 1 network 192.168.5.0, right? And this is something that I want to tell you. The command is wildcard mask. So you give the network address and then give wildcard mask. But OSPF helps you. Even if you were to give a subnet mask, right, and area 0, it accepts it. Not only does it accept it, it converts it to wildcard mask. We can check that here. We go here and we see 192.168.5.0. It is accepted subnet mask and it converted into wildcard mask and done. So as a good practice, don't get used to putting subnet mask, put wildcard mask, because Cisco could ask you the command, and then if you're not used to typing wildcard mask, you might put the subnet mask, and from an exam's perspective that could be wrong, right? So always do wildcard mask, but even if you were to by mistake put subnet mask, it would still accept, right? So that's got added. So most probably that new route should be available here. It is available here. So now let's try pinging once again and see what happens. When you ping now, it is getting reply and it is working. So same thing, let's try to the other network, that is 2.0 network. So 2.0 network 2.10. Again, it says destination host unreachable. Why does it say destination host unreachable? You should know by now. That 2.0 network wouldn't be here. So show IP route 192.168.2.0 network is not in the routing table, and that is why destination host unreachable. But here, this particular router would have got 50 because we already started advertising. So show IP route 192.168. Okay, let's do this. 5.0. It's already there here. So it's just that the packet is not going there, but if it were to go there, it knows how to come back, right? So let's do this. Let's go back to router 2, and if you want to verify, you can do that. Show run begin router, and then we see that 2.0 network is not being advertised. So configure terminal router OSPF 1 network 192.168.2.0.0.0.255 area 0, and we should be ready to ping this particular network. So let's try that. 192.168.5.1 says destination host unreachable, then it goes, then it waits for it, ARP comes back, and then it gets the ping. So now it's working, everything is fine. So let's try this one. Can we ping from here to there, which is also part of our task, PC1 to PC2. We'll go to desktop, ping 192.168.2.10, and we get. So that is your task. It was a very small task. I just wanted to get you all used to it. We will slowly start giving you more and more tasks, and I think it's going to be helpful, right? So if you have not downloaded this, go to our website. From our store, there is going to be a resource called day 46, and that is the one that we just saw. Now we will start another task. We will configure. So go there again, look at the description. You would have this topology. So download this from the link, and yeah, so download this. You should be able to. What I'm going to do is I'm going to because I don't want to confuse, so I'm going to put day 47. I'm going to put one file. So download that file, one zip file, and I will put two files there. One of those files would be this. It would be called OSPF lab. Now basically what we're going to do in this lab is we're going to configure OSPF, and I'm going to explain a couple of new techniques and topics. Then you would have one more troubleshooting lab. So it would be called day 47 OSPF Troubleshooting or something like that. That would be the troubleshooting homework for you, right? So I'm not confusing. I'm just going to put one file, download that file, and you'll have two, and all of this are going to be free. So do that if you're not done then, and you can follow with me. So this topology, I mean, it's very simple. I've configured everything. So IP addresses are configured. So this part is 192.168.1.0. So 1.1 is the router. 1.2 is this PC. 1.3 is this PC. This is 192.168.1.32. And remember, these are all /27. Even these are all /27. So router 1 is connected to PC4 on this 1.32/27. 1.33 is the router, 1.34 is PC4. Similarly, router 2 is connected 192.161.64/27. 65 is the router, 66 is the PC. 192.168.1.96/27 is connected in branch 2, where router 3 takes 1.97 and the PC takes 1.98, right? This interface, the WAN interface or serial interface between router 1 to router 2 takes the IP address 10.1.12, that is saying from 1 to 2, .1, which is the router 1, and .2 is router 2. And this one, okay, I'm just going to put that here just to make it easier. Sorry, yeah. So 10.1.12.0/252, right? So that's this network, and this network is 10.1.13.0/252. Okay, so that's this. There's one more network here, 10.1.14.0/252, but what I'm considering is this link from router 1 to the internet. We don't have to do it because I'm simulating internet here. So this is all internet service provider who is going to give you this part, right? So even this IP address 10.1.14.1, which is to router 1 serial 0/2/0s interface, that IP address is provided by the internet. So we're not going to do anything, or we're not going to configure anything there. We're just assuming that's internet, right? And what I've done, this internet here is nothing but a cluster. So I've created these two. There's a server, we'll call it this Google server, and it's configured 4.4.4.4. And then there's an ISP router. Now ISP router is a link. This is 10.1.14.2. Right, we're not bothered about this, but just know that this router, because this ISP has assigned 10.1.1.14.1 to our router 1, this internet knows how to reach that. That's the only thing we need to worry about. We don't need to worry about anything else. We don't know what protocol or what routing protocol that they're using. It's not our headache. Another thing that I did is I configured Pact, port address translation, if you remember Pact, so that any IP address coming from 192.168/16 IP address, so anything that is going from here to the internet would get patted with this IP address, which is this public IP 10.1.14.1. So that IP would get patted. So if you don't know what NAT is, go back to our PAT and NAT video, watch that, or understand what is patting, right? So that's something that I have configured now. Nothing else is configured. OSPF configuration is not done. So let's see if we can ping from PC0 to PC2. Obviously now we can't because OSPF is not configured, but I'm going to try. So ping 192.168.1.60. This is going to be 66. That's going to be 66, and we know if you get this, most probably when you see it so 4 times, it's definitely a routing problem where you don't have a route. So if you go here, you can verify that. You can say show IP route, and you see that 192.168.1.64/27 is not available anywhere here. So let's do this. Let's configure OSPF. So we go to configure, conf terminal, router OSPF 1, right? That's router OSPF 1. Let's start with this interface. So network 10.1.12.0 0.0.0.3, that's 252 is wildcard mask 3. How do I know that? When you say /252, right? it's not /252. Please excuse me. The last octet is 252. Sorry, my mistake. Sorry. That is what I meant was 255, 255, 255, 252. It's all right. My mistake. Please forgive me. Yeah. So when it is 252 in the last octet, what it means is to get the wildcard mask, you just have to minus 255 minus 252. That is, what is that? So 250. If from the global mask, if you minus everything, this is 0, this is 0, this is 0, and this is 3, and that's what it is. So when you say after that, you say area 0 because we're doing single area OSPF. So that's network done. This part we have configured this, and now this is actively taking part in OSPF. What that means is it is starting to send hello packets to router 2. Not that router 2 knows anything to do with that. Router 2 would accept it and say, I don't know because I'm not configured to do OSPF now. So that's that. Let's do the next one. 3, and it's the same thing. And like I said, you can either do wildcard mask or subnet mask, it doesn't matter. But as a good practice, it's always good to do wildcard mask. So now these two networks, so this interface and this interface has started advertising OSPF, and OSPF is configured. Now we need to do this. So there are 2 ways we can do this. Let's say network 192.168 1.0 and /27. When you say /27, it's 31 and area 0. So how did I do that? I know that when you borrow, 24 is class C, right? 25 is the 4th octet. So 25, when you take 1 borrow, you get your block size becomes 128. When you borrow 2, the block size becomes 64. When you borrow 3, the block size becomes 32, right? So 27 is a 3 borrowal. That means the block size of 32. So wildcard mask is going to be 1 less than the block size. So 31 is the wildcard mask. So I can do this. Now, if I do this, then I have to do another network command 192.168.1.32.0.0.0.31 area 0. So I need to give two network command. I do this, or I could do something else. I could do 192.168.1.0. Now, if you know these two addresses, if you look at these two networks, 192.168.1.0/27, 192.168.1.32/27, these are two continuous blocks of networks, right? If you don't understand this, go back to our day 3 and see how subnetting is done, and then you will see that these two blocks are 232 blocks together. Now, if I keep these 232 blocks together, I can do supernetting, right? If you know supernetting, again, go back to that video and then you know what supernetting is. So I can do something where I can club those 32 and 32 together and make 64 block. So I could say 192.168.1.0, 0.0.0.0.63. Now, area 0. Now, if I do this, what happens is OSPF is now configured on both these networks because of this one command, right? So wherever this applies, 192.168.1.0, 0.0.0.0.63 applies to both of them. So both of them would get activated to operate OSPF, right? So OSPF is running on all these devices, and that's brilliant. Let's go here. Let's do the same thing. So let's do configure terminal router OSPF1 network 192.168.1.64 0.0.0.31 area 0, right? And network 10.1.12.0 0.0.0.3 area 0. Okay, now that's done. Let's go here. Let's do the same thing. Configure terminal router OSPF1 network 192.168.1.96 0.0.0.31 area 0 network 10.1.13.0 0.0.0.3 area 0, right? So that's done, and you'll see that adjacency has also gone from loading to full. That means neighborship has formed. Let's verify that. Show IP OSPF neighbors. We see that it has indeed become a neighbor with router 1. So router 1, it's become neighbor. Let's go to router 1 and see what happens. Show IP OSPF neighbors. Router 1 is neighbors with two routers, router 2 and router 3, which is exactly what we expect it to be. Brilliant. Now let's see if I can ping from PC0 to PC2. So that's ping 192.168.1.67. All right, 66. It is pinging. Let's try if I can ping 192.168.1.96, 97, 98. Is it pinging to 98? Ting ting. I think it should do ARP, and then once ARP is back, it is pinging. Perfect. It is brilliant. It's working. Right. So I said earlier that on the internet I had configured 4.4.4.4, which is one of the servers. So if you go here, this Google server is 4.4.4.4, and they know how to reach you, and I've done NAT pat, so it shouldn't be a problem. So let's try this. Can I ping 4.4.4.4 from here? So it says destination host unreachable. What does that mean? That means this net device, okay, let's say show IP route. He looks at this routing table and it says, I'm sorry, I have no idea where 4.4.4.4 is. I will drop it. Right? So he will drop any packet that is coming to the internet. Anything that is not part of the routing table, it is going to drop. That is because of this. It says gateway of last resort is not set. That means if it doesn't know anything about a particular network, it's going to look at the routing table. It says, I don't know, and it's going to drop it. To avoid that, what we need to do is configure a default route. So that will be configure. let's do IP route 0.0.0.0 is 0.0.0.0. That means for anything, right? Any traffic, if you don't know, this is your next best, right? So IP route 0.0.0.0, it says if you don't know anything, then that has to go on this network. So that is serial 0/2/0. So it says default route without gateway, if not point-to-point interface, may impact performance. So this is point-to-point network, so there's only one interface, so it will do. So it doesn't matter, this is okay. What it's saying is, if at all I need to give an IP address for exit interface, but because I've given the serial, which is port, and it says if it's not point-to-point, which is it is point-to-point, so it shouldn't be a problem, right? So that's fine. So let's try this again. Come back here and say ping, and I'm getting a reply. So the traffic is going from here, it's going to here. It says, okay, I can't find anything on my routing table. That means I'm going to send it out to the internet. It goes to the internet and it comes back, right? Everything is fine. Now that's done. Now can I try from PC2? Now we know that when I ping from PC0, it came here and it went and it worked. But can I go to PC2 and say ping 4.4.4.4? What will happen? It says destination host unreachable, and we know if you're getting destination host unreachable, it means there is no routing table entry. So we'll go there and check that again. So show IP route, and we see that there is no mention of the 4 network, and obviously because there is no 4 network, right? We had to manually configure in R1, but R2 doesn't know. Now there are 2 ways we can solve this problem. We can come here and do exactly that. We can say default route, if you don't know, put a static route on this interface, that if you don't know anything, send it here and let the next device, which is R1, figure out where to go from there. The problem with that is, in this case, there are only 2 routers, so that's R2 and R3 that you need to configure that way. But in your production network, in your office, you would maybe have 100 devices, right? So you can't practically go and configure static route in 100 devices. Now, even if you did, what happens when tomorrow there is a change and then you say, okay, from now our static route is not this, I need to go through something else. What are you going to do, right? There's going to be a big problem. So you need to have a dynamic way. Exactly why we have dynamic routing protocols like OSPF, right? So it defeats the purpose if you go and manually configure a static route. So what you need to do is, OSPF has something called as propagating of your static default route. So that's go to configure, go to router OSPF1, right? And there is this command called default information, right? Default information is used to distribute default information, right? Default route. So let's do this, do show IP route. So now you see that gateway of last resort is set because we've statically configured, and there is a star. What is star? Star is default, so it's default candidate, and S is static, right? So it's static default route. Now, if you have a static default route, now this is a default route, you can go here and say default information, right? Default information, then we say originate and you hit enter. Now what it would do is it would start propagating default routes to all in the OSPF network. So if you go back here now, right, earlier we did not have a gateway of last resort. So I'm going to do the same thing again. Now it says gateway of last resort is 10.1.12.1, which is 12.1. 12.1 is this. So it is telling this is the default route. So if you don't know any route, if it's not in your routing table, send all the traffic to this interface or this router, and then he will take care of it from there. I didn't manually configure, it came through OSPF. You can verify that here. O is OSPF, star is default, E2 is OSPF external. So it's here, E2, OSPF, OSPF external type 2 route. So brilliant. So OSPF has now sent this out, and the same thing would happen here as well. So we could try that here, show IP route, and we see that last gateway of last resort is set, and it is automatically configuring everything. Now, let's try if this works. We go here, we ping, and it would work. We could, because that's a web server, we can even try that web services. So we say 4.4.4.4. It is here, Cisco Packet Tracer. Welcome to Cisco Packet Tracer. Brilliant. So this is here. Everything is working. It's fantastic. Now, traffic is going from here. But can we do this? Now, from here, traffic is going through router 2, and then it's going to router 1, and then it's going to the internet, coming back, and then it's replying. Can we do this? Can I ping from router 2? Okay. What do you think? Yes or no? Obviously, it will not. Why? That has to do with Pact. If you remember our Pact, what is our access list? Our access list is accepting only this traffic, 192.168/16, 192.168.0.0/16. So anything that is in 192.168 network would go through to Pact, which would overload it with this IP address, and then it would work. But if you're pinging from router 2, what is the IP address it's coming as source? The source IP address is coming as 10.1.12.2. It is going to come here. Obviously, router 1 will say, fine, you can go out because that's what you are. You'll go out, but NAT will not work because it's not, it's not, this IP address is not part of the access list. So it will go out as 10.1.12.2. It goes to this router. Router takes that, it says, okay, I know you want to go to the destination 4.4, so it will send that to 4.4. Now 4.4 would reply that back with now destination IP address is 10.1.12.2, but this router, show IP route, he has no information about that 10.1.12.2 because that's private IP, that's inside the network. He knows 10.1.4.0 because, like I said, in our case, this IP address is assigned by them. So obviously, if it's their assigned IP address, they will know how to reach till this point only. So if at all it is going with this IP address, when I say Pact, it is going with this IP address, so it works. If it is not, it will not work. So if you want this to work, there are two things. You can go create from that access list. I can go create, add these 10.1.1.2.0. or it will not work, right? So that's something that I wanted to just refresh you with Pact technologies and what we learned. So that's that. I want to show you one more thing now. Show IP route. Okay, that information was there, but I'm going to show it again here. 192.168.1.0/27, 192.168.1.32. Both of them are connected through the same interface. Everything is same, but two routes are mentioned, right? And both of them are coming from router 1. Router 1 has two networks. Both of them are coming here. Even though in our configuration for OSPF, we summarized that as one, or we did supernetting, yet their routing updates are going as individual networks. Now this is fine, but if you have, let's say, 100 devices, right? You could have 100 networks here, 1.0, 1.2, 2. Whatever, like 100 networks. And if that happens, all these devices working on OSPF in the same area would have 100 networks listed here, which is, you're wasting a lot of space on your routing table. Right? As a network administrator, you're trying to reduce the work that router does. So you're going to have so many networks. Now, this is because, unlike RIP, you don't have auto summarization, right? So the OSPF does not do auto summarization. So it will always send individual routes, right? One way of solving that problem is by creating multi-area, right? Now, what we did in the last 3 videos are single area, right? Area 0, which is the backbone area, which is, if you're doing single area, it has to always be area 0. But if you did multi-area, and for some reason, if let's say this was multi-area, this device becomes ABR, which is area border router. So that means one side it would be area 0, the other side it would have been area 1, 2, whatever, another area, right? And if at all, there is an area border router, an area border router will always summarize. So if there was an area border, it would summarize this and send one route to the routers across. We will do some multi-area OSPF from the next video, but I'm just giving you reasons why we need multi-area. So that's one reason for multi-area OSPF. The second reason is, let's go back here, show IP OSPF. When I do this, of course, with all the information that you see here, one of the information is SPF algorithm. Now, what is SPF algorithm? Anytime there is an update to the link state database, LSDB, once there is a change in LSDB, that means there is a topology change, right? An OSPF being a link state routing protocol, anytime there is a topology change, it needs to recalculate and see if the old assumptions that a certain route is better than another route works now. So maybe there is another superhighway that's come through, yeah? So, I mean, looking at a map that you would do, if there is a new highway, obviously you would start driving through that instead of going through an old, slower route, right? Similarly, every time there is an LSDB change, OSPF would run an SPF algorithm again to recalculate routes and repopulate the routing table. So now your routing table has run 5 times, and as long as there is no change happens, that will always remain 5, right? Even if it runs 10 days, 20 days, 30 days, as long as there is no topology that changed, routing SPF algorithm would be the same. So so that's that, right? Now let's do this. Let's take this and just for fun connect it here. Now what has happened for router 1, there is a topology change. Earlier there was a connection on this interface. That interface is gone. So that particular network itself is gone. 192.168.1.0/27 network is no more now. So whenever there is a topology change, router 1 would create a type 1 LSA and it would start flooding in all the networks. So all the neighbors would get the LSA type 1 update. So router 2 gets a new update in new LSA. Obviously LSDB changes. If the LSDB change, router 2 says, okay, now I need to recalculate myself and see if there is a better way, or if any of my old routes is not valid now. So now you see that SPF algorithm executed 6 times. You see? Why? Because they're all part of the same area. So anytime there is a change in any network, in any part of the area, all routers in that area would have to recalculate SPF algorithm. In this case, the LSDB is very small, so it doesn't take much time. You could have a network where you have 100 devices, 200 devices, whatever. Think about the complexity of that SPF calculation. SPF algorithm running again takes so much of processor time. It slows down the device, and it is just going to be inefficient, right? So like if I do this again, and let's say I put it back there, if I go here, and I will see that SPF algorithm has run again, and now it is 7 times. So every time there is a change, if there's a flap, it need not be physical change. It could be a flap. No, one of the ports flap, it goes down and comes up. That's enough. Just 1 second it goes down, comes up. There is a new LSA that's generated. It recalculates SPF. Again, when it comes back on, it sends another LSA update. It is just going to do that over and over again, and it is going to be a lot of problem. A lot of devices would. So area is a way you would logically start dividing your network, where you say a certain, I mean, that's up to you as an administrator to decide what is your logical boundaries for these areas. So whatever decision that you make, you create it into multiple areas so that these updates, so if at all they were if this section, the blue was in area 0 and these were in area 1, router 1 would stop, the ABR, the area border router would stop that update. So it would, because it's summarizing this network. So this would have been 192.168. I mean, I'm just giving an example. It could have been like multiple things. These devices don't even need to know about it. 192.168 1.0 is actually not his headache, right? They know 192.168 1.0/26 is with R1, and it says it doesn't matter because the R1 is the ABR. The R1 is going to take care of it, and that's not going to get. So SPF algorithm will not run here if they were in different areas. So that's what I wanted to say. So These two are the main reasons why we need multiple areas, and that is what we would be doing in the next video. So we would do multi-area OSPF in the next videos, right? So like I said, if you're not downloaded, look in the description. There is a link. Go to our website, download that. 2 files. One file is a base file for what we did today, so you could follow the video again and reconfigure that. The second video is troubleshooting. So look at that. The troubleshooting task also would be mentioned there. Look at it and try to solve the problem, right? So thank you for watching, and it's been a pleasure. If you like this video, don't forget to hit that like button, and of course click on the subscribe button to be notified when we had a new video, and don't forget to hit that bell icon next to the subscribe button, right? Thank you so much. We will be back very soon, and till then, take care and have fun. Bye bye.